Welcome to Dimensional Data Modeling Day 2 lab. Today is going to be a hands-on exercises that builds on the Day 1 lab where we built a cumulative table that tracks all of the NBA players' seasons and their stats throughout the seasons. This time around, we are going to be taking those data sets and converting them into slowly changing dimension type 2. Because remember, slowly changing dimension type 2 is the gold standard of all the slowly changing dimension types. It's the only one that is purely idempotent. So we're going to be using Postgres in today's lab. If you don't have the stuff installed, make sure to clone the repo in the description below. You're going to need Docker installed, and you're going to need to have that set up before the lab to get the most out of this, because this is hands-on exercises and we learn data engineering by doing here. And yeah, if you want to learn how to do this type of modeling with the hottest technologies like Iceberg and Trino, I highly recommend checking out joining the Data Expert Academy in the description below. First, we need to probably drop and recreate the players table. I made a mistake in the last lab where I didn't add the columns that I wanted for this lab, and I forgot that these labs build on top of each other. So anyways, I'll just go over this real quickly to kind of go over what I needed to add. So we needed this is active column in the players table, which just says whether or not the player is active in the current season. We need that, and then also we want to, all this query does is it does this crazy thing where it generates a series of all the seasons, and then it creates that same array table that we had from the previous session. What we're going to do is, I already ran all that. So what we're going to do is we're going to create a table. We're going to create a table. Create table. We'll call this players SCD. So the main things that I care about two dimensions in that other table, right? So let's go ahead and select some things from this table real quick. Scoring class and is active from players where current season equals 2022. So you'll see in this table we have a scoring class. Let's put player name here. And you'll see with this we have access to the player name, the scoring class, and whether or not they were active that season. And so what we want to do is we essentially want to create an SCD table that models from what year to what year they were either we want to track changes in two columns. Because that's one of the things that's cool about SCD tables is that you can actually track multiple columns at once. And that's what we're going to be doing today. So what we want to do, right, is let's create our players SCD table. What we're going to have in here is we're going to have a player name, and this is going to be a text. And then we're going to have a scoring class, which is a scoring class. We have is active, which is a Boolean. And then we have a current season, which is an integer. And then our primary key here is going to be player name, current season. It's going to be our, oh yeah, we have a couple more things here though, right? So this is, because we're trying to do a type 2, so we need to add two more columns here, right? Which is going to be start season, which I call an integer, and end season, which is an integer. So you're going to have both the start season and the end season as well. So this is now essentially a properly modeled SCD, right? We have our these are our columns we're tracking, and then this is going to be our current season. This is usually going to be the last column. In the big data world, this current season you could think of as the date partition of the data table. So you can kind of think about it that way. And then you have the start season and end season, and then these are the two columns we want to track. So one of the things I want to show here is we want to see how Michael Jordan kind of because he retired and then he came back, right? And we want to see how his records change over time. And we're going to do this first. What we're going to do is we're going to write the query that looks at all of history and creates one SCD record from all of history. That's what we're going to do first. And then after that, I'll show how to then take this query, take an existing SCD, and then build on top of it incrementally, because you can do it either way. So let's go ahead and run this code here, run this create table. It already exists. Great. Okay. So here's a good question. Like, how are we going to do this? Like, how do we create, so players, like, if you ran that other big nasty query I sent you, like, players is going to have data all the way back to 1996 as well, right? You'll see we have all sorts of data in this players table. So how do we create a players table with no filter here? So what we want to do, right, is we have a players scoring class is active. What we want to do is we want to calculate the streak of like how many seasons or how long that they were in this like in a current dimension. And how we do that is we look at like what was the dimension before. That's how we can see how this works. So, and how do we do that? Like, well, we use window functions, right? So let's go ahead and look at lag, right? Scoring class, comma 1. We need to partition this though, right? So we're going to say, we got to put over. We're going to say partition by. And then in our partition here, we want to partition by player name. And then we have an order by. Our order by here is going to be current season. So we can see who, like, and this is going to be as previous scoring class, right? And let's put is active up here just to keep things going. So then we want to just essentially copy this again for is active. And then this will be previous is active. So this will be, depending on what the previous season was, that will be what we get out of this. So if we run this, you'll see, oh, we need current season in here as well. Let's put current season here. So you'll see, okay, like here is AC Green, 1996, he was bad, and is active is true, right? His previous, you'll see his previous scoring class and previous is active. These are both null. So like, you can see that this, like, when it's a line like this, that means null. If it's empty, that means false. So that makes sense because he didn't play in 1995, or there's no data for 1995, so that makes sense. But you'll see how you can go forward and forward and forward here, and like he essentially was just bad the whole time, right? And so you can see like other players, like they're pretty consistent, right? But this might not always be the case, right? Where so what we're going to do is we're going to create a CTE here. We're going to call this with previous. All right, and then as I say, select star from with previous. So then in this case, what we can do is we can create an indicator of whether or not it changed. So what we can say is like case when scoring class does not equal previous scoring class, then 1, else 0, end. This is, we can say, put a then and an else and an end. We're going to call this as, and this is going to be change, scoring class change indicator. And we need to have essentially a similar bucket here where we have case when is active does not equal previous is active. And we can say is active change indicator. So let's go ahead and just run all of this, and I think this will make a little bit more sense. So we have our players here, and see how we have these change indicators? If we sort here, do we have, okay, so see, here's someone here. He was, so Aaron Brooks, you see how like he went from bad to average, and then he went from average to good? Wow. So it looks like he was really ramping up here from 2008 to 2009, right? So it looks like he changed 2 times like in like back-to-back seasons, right? And then, oh yeah, and then, but then he kind of faltered, right? So you see how he went from good to average? So these are the kind of changes that we're looking for, right? We're trying to see like how people like are changing and like how they are going about their changes. So this is great. So what we want to do here, right, is we essentially want to create a streak to identify when, like, for every change that they have. So imagine the first time they enter, they get 0, and then the next time they make a change, they get 1. The next time they make a change, they get 2, and so on and so forth. So this is, we're going to put this, we're going to say like make a new CTE here with indicators. So this is now, this is great. So what we want to do is, there's 2 ways to go about doing this, right? Is like really we want to track these things together, right? And I think that that's probably something we want to do here. Like these 2, like it gets complicated if we have 2 indicators like this in this pattern. So what we actually want to do is combine these into one single indicator, and that's pretty easy. So what we're going to do is we're going to paste this up here, this case when. And then we're going to just call this, instead of scoring class change indicator, we're going to call this change indicator, which is where if there's a difference in scoring class or is active, so like if they go from good to bad or bad to good or from active to inactive, then this will indicate that they did that, right? So now what we want to do is we want to create, let's look at this. So we say with indicators. So what we can do here is we want to essentially sum these up so that we can keep track of the streaks for players, right? So in this case, what we can say is you can say row number. No, we want sum. My bad. Sum. In this case, we're going to say change indicator. But this is actually going to be another window function. In this case, we're going to say over. And then again, we're going to say partition by. And then in this case, our partition by here is still going to be player name. And then our order by here is going to be current season. And then this is going to be as streak identifier, which is probably like, what is Zach doing here, right? So let's go ahead and see what's going on here with a certain player, right? So here's AC Green, who like seems like he was active and bad for like a long time, right? So let's go look at streak identifier. You see how streak identifier, okay, so he did change here though. So you see he became inactive at this point. So you see how his identifier changed to 1, and then it looks like he was just inactive for like the rest of the data set. So, and you see how like that's all in the same, that's all the same value here, right? So you can see exactly when he became inactive. So this is exactly what we're looking for when we are trying to build out these SCDs, is we are looking for like how long they stay the same value. And you can kind of see how different players kind of progress and change their values over time. And some players are only active for like 1 year. So what we can do is from this data, right? Now we have one more window function here. So we're going to call this with streaks as, and this is going to give us our streak identifier. So now what we want to do is we essentially can aggregate on this identifier, right? Because if we do a min and a max on this identifier for the season, that will collapse all of these rows, right? Because we know that all those values are going to be the same, because we just proved that out with how we are doing this with the lag and the lead and all that stuff. So in that case, right, what we can say is we can say select, we're going to say player name, and then we're going to say streak, or we're going to say from with streaks. So in this case, we want to do player name, and then we can say streak identifier. And we want to do a couple, we probably have a couple more here. We have is active, and then we have scoring class. And then it gets a little bit interesting, because then we can say max. We can say max current season as end season, and min current season as start season. Oh, well, let's put this. Usually you put the start before the end there, right? And then this is now, this is a regular aggregation, right? So in this case, we can say group by player name, streak identifier is active, and scoring class, right? So now this will collapse all those records, right? So now you'll see we have these players who are in here, and they are like, some of these are for a long time. See this 2003 to 2022, this guy, right? And then some of these people change a lot, right? Like this guy changed 10 times. Wow. Like, so what this is doing, right, is you can see with these people, you can, like, a lot of times, like, when people do this pattern, they actually don't, you group by streak identifier, but you don't include it in the data set, right? And then what this does is, well, let's put an order by in this to kind of really make this pop. So we can say order by player name. I think that will really make this pop a little bit. So remember we had that AC Green guy, right, where he had just that one change where he went from active to inactive, right? So you'll see here how he was active from 1996 to 2000, and then he changed in 2001 to inactive, right? And then from 2001 to 2022, he was inactive. So what I'm trying to illustrate here is you see how this is essentially it. Like we essentially have what we're looking for now. This is our SCD sort of table. One of the things that I think we should do for the later part of this lab is we want to filter this down just a little bit. And what I'm going to say here is I'm going to say where current season is less than or equal to 2021, just so that we can use 2022 in the incremental build of this. So what we can do is let's run this code again, and you'll see now this goes to 2021, exactly what we were expecting. And you'll see, okay, here's AC Green with the ordering. And so 0 is their first streak and 1 is their second streak. And so you'll see, like, okay, this makes sense. Let's find someone who, like, is a little bit more interesting. Like this Aaron Brooks guy, right? It's actually, like, put streak identifier in there as well, like the order by, so it's not so freaking ugly. So you'll see this now actually explains the entire history for people. So, like, this guy started out as bad and active, then average and active, and then good and active. Like, he just, like, was, like, 1 year at a time, bang, 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 right? Well, he changed a lot, right? Like, this guy, okay, then he did have a, it looks like he went inactive for a year here, right? And then here he finally had 2 years where he was at least consistent. This guy, like, wouldn't even say he's, like, slowly changing, right? He's changing almost every season. So, like, but it depends on who the player is, right? And, like, so the streak identifier is just, like, the first value, and then each one after that is every time it's changed. And so that you can get the continuous values that you're looking for different players, and, like, over what time frame that it exists. So that's kind of the idea behind how this streak identifier works. So what we can do here is, the last thing we have in here is this current season, which actually we want to just hard code. This is going to be 2021 as current season. Because this is like, imagine if this was in, like, Airflow or, like, some sort of pipeline, that this is a parameter that you would inject, right? This guy. So this essentially is the query that we're looking for. I think we can say insert into players SCD. Oh, what did I mess something up here? There's like a what are the columns in this? Okay, so you're right. Streak identifier is not in there, and it's like score. Okay, scoring class is first, and then is active. And then start season, end season, current season. Okay, that looks right. Okay, so now this is our kind of way of, so the main thing I'm trying to show with this is a way of processing all of history. And, oh, it already exists? Let's see. Players SCD. what? Oh, because there's a duplicate in the primary key. Because the primary, I messed up. I actually messed up. The primary key is not that. It's the primary key is all three. It's the start season, end season, and the player name. It's all three of those. Small little mistake here. So drop table players SCD, and then in this case, primary key here is going to be player name, start season. I think it's actually just player name and start season. Because, yeah, you don't have to put end season in there. Like, you could potentially put it in there, but, like, they should only have one value at the start of each season, or at the, like, for that value. So I'm pretty sure that's actually the primary key, not current season. It's start season. So you can go ahead and create that table one more time, and now this should actually run. Okay, now it runs pretty great. So now we can just say, like, select star from players SCD. And this should... Okay, great. This gives us the same data, right? Exact same data that we had before. And so this is awesome. So this is essentially how you can create an SCD table from your whatever data you have, like your daily data, or like, because you can think of the season here. You could change that to date or year or month or whatever, and like you can have the same exact values, right? That could be a big thing. That can make a big difference here. So that's a big part of like SCD stuff that I highly recommend like checking out. Is just like this is this can be very powerful. There are some things about this pattern that I don't like, and let's kind of go over those before we go into the incremental build, just so that you can kind of see the difference between the two. So there's going to be some expensive parts of this query. The big expensive parts of this query are these windows, right? Like, look how many times we have to slice this up, right? So we have 1, 2, right? And then we have 3. So you essentially have to do two window functions on top of each other and then an aggregation, right? And this is the only time we aggregate. So you actually do window functions on the entire data set, right? Like, you never crunch the data down anywhere, right? It's only at the very end when you do this big group by that you end up actually shrinking the data volume at all. And that is, it's good because like you have all the data and like you have the full history, which is very powerful. And now you have this beautiful little SCD table that like really explains and really makes things pop, right? It really shows how people like play and do their thing. But like it, this only works, like this query really only works a lot like given the scale, but this query like also is powerful. So like when I worked on unit economics at Airbnb, this essentially was the query we worked with. And we did this for all the different line items and all the different things in that table. And it worked great. Spark was able to crunch this pretty well because it's like these window functions are actually not that expensive. Like if you just partition things up and like slice and dice it. So like, and then you can essentially just regenerate all of history every day, right? So then you can change this like the next day, right? So like you would just change it to like 2022, 2023, 2024, right? And then you don't even have to think about the incremental, right? Even though like the data engineer in me, like who cares a lot about efficiency, is like, I hate this. Why am I scanning all of history every day? I don't like this at all. And that's a big thing that I think y'all should definitely be looking into, is like how that is impacting stuff. Is but most of the time, like this can be enough, and this is going to work for you. But on the flip side, I also love teaching about the other ways that things can be done, because this query here versus the query we're about to do, this query here is going to be a lot more prone to out-of-memory exceptions and skew and other interesting problems like that. For example, if you have most of this is a slowly changing dimension, but you saw how we had that one guy who was like changing every single year. So imagine if you have some people or some dimensions in your data set that are not as slowly changing as other ones, then the problem here is that you get a lot of streaks for that specific user, and then that blows up the cardinality of this, right? And that kind of like slows it down. And that's where like when you're doing this, like they should all have roughly the same amount of slowly changing. But obviously that will never be the case, but that's what you're kind of hoping for. But like that's where I like these queries. I like this query. I think this query works great. I ran this query in production at scale. So like don't worry too much about that, because that's one of the other things I want to like really advise y'all with is when you're working with dimensions, you can do like crazy stuff like this. Like you can do like, I'm just going to scan all of history. Like you can do that because dimensional data really isn't that big. Like dimensional data does, even at Facebook when it's like billions, it still isn't that big compared to like where the fact data goes, right? The fact data is just like, can be billions and trillions and just really, really, really large. So like, you know, that was one big thing that was different between Airbnb and Facebook, though, is that this query probably wouldn't fly at Facebook because they have billions of users, whereas at Airbnb, there's like millions of users. And so you have like a kind of a, there is a line there of scale when you add like one or two more zeros where you can't just like throw everything into a window function like this and call it a day. So that is definitely something that you want to be considering as you kind of like are going through your career and going through all sorts of stuff. So yeah, let's go ahead and get into this next kind of way of doing things, right? So what we want to do is, so we have players SCD. So what we're going to say is we're going to say with yesterday data as, in this case, we're going to say, what was it? I call this last season SCD. Select star from players SCD where current season equals 2021. And then we have this season data as, and in this case we have select star from players where current season equals 2022. So what we're trying to do here is see if things have changed, right? So the thing is like some of the SCD records we don't have to care about, and we know that they're never going to change because they like they're already completed. They don't have that current record to them. So the thing is like, so this last season SCD, what we want to do is we have one more thing in here, and that's going to be end season equals 2021. Because then we want, then we have historical SCD as, and then historical SCD is going to be this guy. But this is where end season is less than 2021. So because in this case, like if someone has already, like for example, Michael Jordan, he like retired in 1997 and then he came back in 2001. Those records are never going to change. Even if something happens in 2023, there's nothing that can change those records because they have already started and ended. So that's what this historical SCD is doing. And then we have last season SCD. So let's go ahead and just like look at that select star from last season SCD first, just to kind of like get a grapple of what's going on here. And you'll see that like we're going to only have one record for everyone here, right? You have this 2021 record, and like it's going to be where all of these are going to be like, these are the current records, like assuming that we have all the data up to 2021, and then like 2022 could, for the records that don't change, they could just increase one, and then for the records that do change, we need to add a new record. That's essentially how this is going to work, right? So how are we going to like look at this? I think that there's going to be a couple different ways that you could think about doing this, right? So one is, let's look at like, so if we join here, right? So let's say from last season SCD, let's call this LS, join this season data, TS. All right. This is actually going to be a left join because there might be, actually, yeah, it'll be a left join, right? Because, oh wait, it's the other way around because this season can have new data because you can have the new players who didn't come in, right? It's actually this way, last season SCD. And this is actually just, yeah, and then this is a left join because you can have those new players who don't have any records yet. And then this is going to be on ls.playername equals ts.playername. And so this is going to give us, okay, so in this case, what we care about here is we want ls.playername, and then we want ls. Let's change this. This is ts, and this is ls. There we go. And this is ts.playername, and then we have ls dot scoring class ls.isActive, and then we have ts.scoring class, ts.isActive, right? So these are going to be the main things we're going to be looking at. So you'll see in this case, like, these players are mostly going to be the same, but some of these are not, right? So like this Aaron Henry guy, you see how he is not the same. His record changed. So in this case, we have, we can have the changed records, and then we have the new records, right? So that's going to be essentially the way to think about this, right? So we have the changed records and the new records. So in this case, let's go ahead and add in here, we have, this is going to be, let's call this unchanged records. Call that first. Okay, so in this case, what we want here is there's a nice where condition here. And so there's going to be two things here. Like first off, this is not a left join now. This is just a regular join because we'll have the new and changed records. We'll have new and changed and then unchanged records. And then those will be our kind of all of our things going together. So in this case, we just have a where clause here where it's like where ts.scoring class equals ls.scoring class and ts.isActive equals ls.isActive, right? And then in this case, what we have is we want to essentially keep all of the records that we need here. So we have ts.playerName, and then we have ts.scoring class, ts.isActive, and then we want to have then we have the ls.start season, and then in this case we have ts.current season, and this is going to be as end season. So what this is going to do is, for the records that don't change, we're just going to increase it by 1. So let's go ahead and just look at that. We're going to say select star from unchanged records. So this is going to essentially expand it out 1. So you'll see we have like AC green, right? And see now he's going to go from 2021 to 2022. And so that's great. Like he's going to be in there, and that will be awesome. So then we have one more in here where we have the new and changed records. That's going to be the other kind of the other pieces of this puzzle that are going to be kind of an interesting piece, right? We have unchanged records, and then we have new records, right? Or new. This is new and changed records, right? Because those can go together. So in the changed records category, the problem is like you actually end up having 2 records, right? You have the record for the change, and then you also have the record for the closed record, the one that like just finished, and then you have the record for the change. So in this case, what we want to do is we want this in here, right? And then this becomes a left join here, and then this where clause is interesting, right? So it's going to be or. So I'll show you how this works. So you have this as an it's like they either one of them doesn't equal, either the scoring classes don't equal or the isActives don't equal. But then there's another one that's like or ls.isActive is null, right? Or we can just say ls.playerName is null. And that will give us the new record, the new and changed records that we can then work with. So in this case, right, one of the things that we can look at, right, is this one is a little bit trickier. So you really want to use like an array of struct here kind of thing, right? Because you have to essentially take one record and make it 2 records because there was a change that happened, and so you have to have both records in there. I hope that makes sense. So in that case, like what we want to do is we want to create a row, right? In this case, which is going to be wait, is this going to be? I think I made a mistake here. I think this is just changed because then new is like the last one. You have like one more that gives you new, which is just going to be where player is null, and then you just pull it in. Yeah, okay, so actually this is just changed records. So, and all these go together. I know this is like kind of a lot, but it'll make sense. So in this case, we're going to put an array here, where we need to unnest this array, essentially. Where what we have is we have a row here, which is going to be these, like, well, because you have the old record and then the new record. They kind of like go together. And I think we actually have to create a type here, because Postgres is weird. In Spark and other places, you don't have to worry about this because Spark can just handle it. But we need to have one that has these values. It has like the SCD type. So I think we'll go ahead and do that up here. So create type SCD type. And then this type has, we have scoring class, and then we have is active, Boolean, and we have start season, integer, and end season, integer. And I think that's all we need is that. And then, because then, yeah, then the player name is going to still be here because we join on player name, so that will be fine. So we don't need player name. And then, so we'll create this type here. Okay, so now in the row here, right, we need to put these in here. So we have the old record, which is just going to be all of the old record stuff. So we have ls.scoring class, ls.isActive, ls.startSeason, ls.end season. And then we have, and then we need to cast this as an SCD type. Then we have another row here, same idea, but these are now all, we have TS, scoring class, TS. So these don't exist yet, right? Because they are, this is going to just be current season, and this is TS current season, right? Because the new record is just one value. It's just like the current season, 2022. And then, so this is an SCD type as well. And so this is going to give us our kind of values that we're looking for. And the good news is here we can get rid of all of this, right? Because this is not what we need. And then what you can do in this is like we can do like an unnest. So this is going to give us an unnest, which then we have as this will be. Let's like look at like what this this looks like, because this is going to be a lot of changes here. So let's go ahead and look at like what this query actually gives us. So I'll comment this out, and then we can run this. Okay, so you'll see we have our changed records, and it now has, is that right? Because we have changed records where, yeah, and then this is not there. So this is going to be our, okay, there we go. So now we have our changed records, and it has like, there should be two, what? Oh yeah, because it's not like, oh yeah, there we go. So you see how now we have two records. We have the old record and then the new record for things that changed out. So what we can do is we can actually, we probably want to just flatten, or we want to like get it out of the type, out of the struct. So we can say like unnested changed records. And then in here, we can just say select star from changed records. Let me change it as records. Let's call this as records. And we have a player name, and then we have records. And then this is an SCD type, though. So now what we can do is we should be able to do, in this case, we can say start season. So we can just essentially flatten this guy out. And we can say scoring class. There we go. Scoring class. And then this is we have is active. And then we have start season, and then end season. Why is it? Isn't that what it? Yeah, start season, end season. That is. Like, okay, there we go. It's just like it's. Okay, so now we have, this is our unnested change records. And I know that this has like been a long query in the making right now, but you'll see now we have this broken out to where these are all the players who had any sort of change here, right? That's going to be our last, like, so you see how now we have two records for all these. These are all the players who changed. So we have one last one here, which is our new records, right? New records is easy though. So I'm just gonna, what we want to do here is we're gonna say select star from this season data, TS. We're gonna say left join last season SCD on ts.playername equals, we'll put this as ls.playername. And this is gonna be where ls.playername is null. And then what we want here is for TS, we want to say ts.playername, ts.scoring class, ts.isActive, and then we want ts.current season as, it's going to be start season, ts.current season as end season. Okay, so now we have everything ready to go. We just have to now just essentially union all of these together. So we have, so we're going to say, in this case, we're going to say select star from historical SCD union all, and then we have select star from unnested change record union all, select star from new records. I think union all must have the same number of queries. Okay, what same number of columns? Okay, what did we miss here? 1, 2, 3, 4, 5. And this has 1, 2, 3, 4, 5. And then, oh, there's, yeah, we have unnested change records, new records, and then historical SCD. Oh, because historical SCD has that current season in it. That's the problem. It has that like last value, right? So what we can do is, but we don't actually ever use current season in that table. So what we can do here is we can just pop in player name, scoring class, is active, start season, end season. So now this should work. There we go. Okay, so now we have, this is the way to do it incrementally. So now, like, the good thing, I know this query probably looks really insane, but it's actually, it's processing a lot less data because we're only processing the compacted 2021 records and then the 2022 records. So this is probably processing like about 20 times less data. So even though it's like the query is a little bit more complicated because you have to think about all the different ways that things can change, it's also a very powerful query where you can, where everything kind of comes together and it like is pretty freaking cool how this stuff like ends up working. So I think let me run this one more time. Okay, so we have this, and then it has all the players and what they're doing. And so this is the idea behind how you can kind of incrementally add more and more players in here, and that's kind of the idea. So this is like, I think I did it in a slightly different way in the last lab, but like I like this way of doing it because it's very clear of like the way that this works. Oh, actually, there's one more union here. Actually, right? There's the select star from, there's the unchanged records, right? And then union all. Yeah, that's actually what it is because you get all of this. There we go. And then that like is the records that we're looking for. Yeah. And so this is like a lot, right? And this is one of the reasons why, like, when I was working at Airbnb and looking at unit economics and everything, and I'm like, dude, I don't know about that. I don't know about writing this query, right? This query is freaking gnarly, and like, there's so many like edges that can happen here and different things that like you want to be aware of, right? So like some like for example, there's going to be a couple other assumptions here that you want to really think about, right, for these queries to make them work the right way, and like, where these problems can happen a lot, where one of my big assumptions in this query that like we didn't even really talk about is the fact that I assume that isActive and scoring class are essentially never null, right? Because if they ever get nulled or nullified or whatever, then it kind of breaks this pattern. It breaks a lot of this because like then like for example, null right here, right? Here's one, null, null doesn't equal null, right? And like this, it would get filtered out here, right? Whenever you do a comparison like that, where it's like if something doesn't equal null or null doesn't equal null, that's where there's like that other query. There's like another one. There's like the is distinct from, and that's where like you can actually handle null in these cases. But like I never use those. I always end up using like the hard equal signs and does not equal signs. So, but like that's a big thing to remember about your query patterns is that they can be like that, right? You can have all sorts of different things that can happen that like can mess things up. And that's why it's important to have your assumptions checked and your quality assumptions checked when you're building out these queries. And so in this case, this query is going to work better in a lot of cases because it's querying a lot less data. And so this query will work way faster, but it also has a sequential problem, right? Because now we are depending on yesterday's data, because you see how we have like historical and then current, and that it makes it a little bit harder to like backfill, and that part of it's a little bit annoying.